Temperature, position, light intensity, sound waves, colors, and textures. Our world is filled with analog quantities that do not fit into restricted measurement systems such as on versus off or small versus big. When we use a plot to visually represent the values of these analog quantities, the curve will be smooth. The most emblematic of these smoothly varying analog curves is the sinusoid. In the context of modern electronics, digital implies binary, where the only available digits are 1 and 0, and engineered systems can provide vastly superior performance and functionality when electronics store, transmit, and process information digitally. In typical single-ended digital circuits, a logic high signal has a voltage that is equal to the supply voltage, and a logic low signal has a voltage that is equal to the ground voltage or 0 volts. If the supply voltage for a digital circuit is 3.3 volts, electrical signals would resemble rectangular waveforms that transition between 0 and 3.3 volts. In many applications, digital operations are so advantageous that electrical engineers employ digital techniques even when this creates a need for additional circuitry that converts quantities from analog to digital and then from digital back to analog. A large proportion of the activity performed by a modern electronic device occurs inside integrated circuits. Consequently, the difference between analog and digital circuits is rooted in the difference between analog and digital integrated circuits. Analog and digital ICs contain the same basic components, primarily transistors, but also diodes and passive elements. However, in analog ICs, transistors are intended to amplify or produce continuously varying signals. When we bias a transistor, we create circuit conditions that allow it to properly respond to small changes in voltage. For example, an input stage of an amplifier IC might employ the MOSFET differential pair configuration shown here. Note that the current source, I-bias, is biasing the Q1 and Q2 transistors. This circuit, called a Colpitts oscillator, uses a biased bipolar junction transistor to generate a sinusoidal signal. Digital ICs, in contrast, are designed in a way that allows input signals to turn transistors fully on or fully off. Whereas both MOSFETs and BJTs are found in analog ICs, the vast majority of transistors in digital ICs are MOSFETs. Designers interconnect MOSFETs in order to form relatively simple circuits that implement basic Boolean logic functions, and these logic gates can then serve as the building blocks for higher-level digital circuits such as flip-flops, and even for exceedingly complex circuits such as microprocessors. For more details, check out the link in the description or visit allaboutscircuits.com.